Hi, I'm David.
And I'm Anshul, and we'll be explaining physics and sports.
A lot of people love to play sports, but do they really understand the underlying physics concepts? We'll show you here.
Observing rotational kinematics in turning. As I'm turning, at first my leg is distributing the mass further away from the axis of rotation. When I bring my leg in, I have less rotational inertia and am able to turn faster with a higher angular velocity. In this clip, we see that when humans are involved, energy is not conserved. Although the gymnast gains spring potential energy from the springboards on the floor, her initial kinetic energy comes from the calories she consumes in her food. In order to maintain your balance, you must keep your center of mass over the area of contact with the floor. In this picture, we will be modeling the girl's body as a circle and rod, both of uniform mass. We can see that her overall center of mass is over her foot, so she is able to maintain her balance. In reality, the girl's center of mass is slightly higher because her torso is more massive than her leg.
But we're going to go over a couple of the problems that people have that hinder their shot speed. Problem 1. Hand placement. The lacrosse stick works as a lever, with the top hand and the bottom hand creating a torque that turns the axis of rotation. In this example, the axis of rotation is very high up on the stick. It was about where the tape is. Now I'm putting my hand actually where the tape is, so that I have much more leverage on the stick, and the head of the stick, where the ball is, has a much greater range of motion. Therefore, the angular velocity in both examples, omega, is the same. However, the velocity of the ball is much greater in the second example because the radius from the ball to the axis of rotation is much greater. In the equation, V equals R omega. Some only focus on the arms, but the whole body is integral in creating a fast shot. Here we will be focusing on the motion about the vertical axis from my head to my feet. In this first clip, I do not wind up my hips or my torso, and there is no range of motion about that axis for me to use. However, in this clip, I use the crow step to cock my hips so I get the maximum range of motion for me to apply a full body torque and whip my leg around to create the maximum torque possible. Note that torque equals I alpha, so this angular acceleration then creates an angular velocity, which in turn creates angular momentum about that axis, which you should not stop, because if you try to stop that angular momentum, it will also stop some of the momentum of the ball. That is why you must follow through with your shot and continue the angular momentum.